In section 4.8, we're just going to be talking about applications of our trig functions. So we're going to be using right triangle trigonometry to solve story problems. So we just have a few examples to go through here. The first one is we're just going to solve for the right triangle. So if they tell you to solve a triangle, the idea here is you're solving for any missing angle or side. So when we look at this triangle, we know that angle C is 90 degrees, and they gave us that angle A is 34.2, which means that if we wanted to solve for angle B, we know that angle B would just be 90 minus 34.2, right? Because they all have to add up to the 180. So if we do 90 minus 34.2, we get that angle B is 55.8 degrees. So we know that this is 55.8. Okay. Then we're going to use some right triangle trig to find sides A and C. So let's start with side A. I'm going to use the angle measure they gave me because I know that's correct for sure. And so I want to find the opposite side, and I'm given the adjacent side, which means I'm going to set up a ratio for tangent. So the tangent of 34.2 equals A over 19.4. If I multiply by 19.4 times the tangent of 34.2, and again, remember that your calculator, because 34.2 was in degrees, your mode on your calculator also needs to be in terms of degrees. If we do that, we find out that side A is 13 point, and we'll go 1 decimal since everything else on here is 1 decimal. So this is 13.2. Now to find side C, you could technically do Pythagorean theorem, but because 13.2 is a rounded number, I probably wouldn't use that in my calculations unless you absolutely have to. And in this case, you don't have to, because we could go back to this angle of 34.2 and the side 19.4, which is the adjacent side, and find the hypotenuse. So with the adjacent side and the hypotenuse, we could use the cosine of 34.2 equals the adjacent side over the hypotenuse. So let's get the C out of the denominator. So we would say C times the cosine of 34.2 equals 19.4, or C equals 19.4 divided by the cosine of 34.2. And so we end up with C equals 23.5. So in the next one we have this picture, and it says we have a point 200 feet from the base of a building, and the angle of elevation from the bottom of the smokestack is 35 degrees. So the smaller angle is 35, and the larger angle, this whole thing right here, is 53, right? And we want to find the height of the smokestack. So what we're going to do, what we're going to have to do is use the small triangle first, right? So if we just use this triangle here, we can find the height of the building. So if we were to set up, we have the opposite and the adjacent, right? So that's a tangent. So we could say that the tangent of 35 equals A over 200, or 200 times the tangent of 35 equals A. So we get that the building is 140.042 feet. But then we don't have information for just the smokestack. So what we're going to have to do is to take the big triangle, which is a smokestack, plus the building, and find that side there. Right, so still tangent, but let's call this side over here, let's just call it P for the total smokestack and building. So we'll say that the tangent and that angle, they told us was 53, would equal T over 200. So 200 times the tangent of 53 equals T. So we get that the combination of the building and the smokestack is 265.409. Right, so if we want just the smokestack, so just this part right here, we have to take our whole total, our 265.409, and subtract the building, so the 140.042. Right, and that would just give us the smokestack. So we get that the smokestack is 125.367 feet. And then our last example, it says, from the time a small plane is 100 feet high and 1,600 ground feet from its landing runway. Okay, so what this picture looks like is we've got this plane that's in the air, 100 feet, and it's going to land somewhere down a runway over here. So that's the 1,600 feet that they're talking about. And the plane descends into a straight line to the runway. So we need to determine the angle of descent in degrees. So your angle of descent, that's the same as your angle of depression, which is always based on your horizontal. Right, so if that's your horizontal, this is the angle right here that we're looking for. So what we could do, though, is we could think about creating this other triangle right here. Oh, you guys, you know what? I'm sorry. Ground, I didn't read ground feet. Well, I did read it, but I didn't think about what that meant. So ground feet, let's not put the 1,600 there. The ground feet is along the ground, right? That would make sense that this side right here would be 1,600. So I'll give you a minute to change that if you're writing this down. Sorry about that. We're going to assume that this is a right angle. And again, we're still looking for this angle measure up here. So if you were to just stack the triangle, you could do a couple things. We could use opposite interior angles to say that this is the same angle down here. Or you could just take these measurements, and because you have a rectangle, you could put them on this kind of imaginary triangle that we drew up there. So to find this angle, right, we're going to use, we have opposite and adjacent. So we're going to use the tangent of theta equals the opposite over the adjacent. And to get theta by itself, we have to take the inverse tangent of 100 over 1,600. And so in your calculators, again, we're in degrees. Your inverse tangent is just second tangent of 100 over 1,600. And so we would get that our angle is 3.58 degrees. So obviously my triangle is not drawn to scale, but you probably wouldn't want a plane descending a whole lot more steeply than, that 3 or 4 degrees.